Pluto, hidden in the dark corners of our solar system and the depths of space, which was once the 9th planet of our solar system. It had found a place in the imaginations of people and scientists. Since its discovery in 1930, Pluto remained a mystery to us. But in 2015, the New Horizons spacecraft made a historic flyby, and then we received some remarkable images of Pluto. Scientists were amazed because there were far more mysterious things happening on Pluto than we had expected. New Horizons revealed Pluto's dynamic and complex nature. It presented us with a view of a world where we could see massive glaciers, tall mountains, and a faint, hazy atmosphere. But as we studied Pluto, a very strange question emerged. Could there be life hidden somewhere in Pluto's icy world? At first glance, Pluto doesn't seem like it's made for life at all. It's extremely cold, with temperatures dropping to around -225°C. It's very far from the sun, where even sunlight barely reaches. Despite such harsh conditions, some recent discoveries have astonished scientists. These discoveries suggest that the ingredients necessary for life exist on Pluto, but they are buried beneath Pluto's frozen surface. Today, we are going to explore the possibilities of hidden life on Pluto. We will examine the conditions on that planet and also look at some surprising discoveries by New Horizons that indicate the possibility of life in Pluto's extreme environment. The question is quite big. Despite such harsh conditions, is Pluto still harboring life? To understand the possibility of life on Pluto, we first need to understand the conditions present on this dwarf planet. There is a region in the Kuiper Belt which is much farther than Neptune, the last planet of our solar system. This region is filled with icy bodies. It is believed that these bodies are remnants of our early solar system. Pluto is also a part of these icy bodies in this region. This is an extremely cold and frozen world. Its surface is mainly made of nitrogen ice with traces of methane, carbon monoxide, and water ice mixed in. The surface temperature of Pluto is among the lowest in the solar system, with an average temperature of -225°C. Such extreme temperatures mean that if there is any water on Pluto, it would be completely frozen solid. The kind of life we know cannot survive in such harsh conditions. However, recent discoveries suggest that Pluto may not be as harsh for life as it appears. Scientists have seen some rays of hope here. The most remarkable discovery made by NASA's New Horizons mission is about the presence of subsurface oceans beneath Pluto's surface. The discovery of this hidden ocean came to light by observing a surface feature of Pluto, Sputnik Planitia, a large heart-shaped region on Pluto. It is believed that this area is made up of nitrogen and methane ice. It has been active. Scientists are sure that with the help of subsurface oceans on Pluto, they can explain all the features they are seeing on Pluto. For example, when water freezes, it expands due to the changes that occur in its internal structure. And we have also seen this effect on Pluto's surface. New Horizons has made Pluto even stronger because ammonia works like an anti-freezing agent which lowers the freezing point of water significantly. Ammonia doesn't freeze even when the temperature goes below zero. If subsurface oceans exist on Pluto, they could be an ideal place for life. Even on Earth, we see life thriving in many extreme environments. For example, around hydrothermal vents in the deep oceans where organisms survive on chemical energy without sunlight. Such conditions could also exist on Pluto, where life might be thriving beneath its icy surface, relying on chemical reactions and geothermal energy. As far as we understand Pluto, the possibilities are endless. Another astonishing discovery from the New Horizons mission was the evidence of ongoing geological activities on Pluto. Before the flyby, scientists thought that Pluto was a cold and dead world where there would be no geological activity. But what they saw was a landscape that was completely different from their expectations. On Pluto's surface, you can see many different types of terrains. There are some very large plain areas, some big peaks and mountains, and in some places there are deep valleys. But there is a very large heart-shaped region which is made mostly of nitrogen ice, and its upper surface seems to have formed recently. Here, you can see only a few impact craters on Pluto. This shows that the surface of Sputnik Planitia is being formed repeatedly. It is possible that this is happening because of convection currents in the subsurface ocean beneath that icy surface. Several other pieces of evidence related to geological activities on Pluto were also found in Pluto's mountains, which are primarily made of water ice. These mountains are up to 350 meters high, such tall and large mountains. This means that Pluto's crust is made of strong and stable water ice, which is capable of supporting such massive structures. Mountains made of water ice and plains of nitrogen ice on Pluto indicate a complex and active geology. But one question that was troubling scientists was, what exactly is driving these activities on Pluto? The thermal energy generated by radioactive decay in Pluto's core was considered as a possible explanation. When radioactive elements break down, they release heat, which is so much that it can drive subsurface oceans and geological activities on Pluto's surface. Another strange possibility is cryovolcanism, or in other words, ice volcanoes. On Pluto, unlike traditional volcanoes, molten rock or lava doesn't erupt. Instead, the volcanoes here erupt substances like water, ammonia, and methane. New Horizons observed very large dome-like structures on Pluto's surface, which could possibly be cryovolcanoes. And if that's the case, liquid water and some chemicals would be strong evidence of a subsurface ocean on Pluto. First, it would mean a new surface is being formed, and second, it would be strong evidence of liquid water beneath the surface. This is what it suggests. Liquid water and some chemicals are reaching the surface from beneath, which is causing a new surface to form and also confirming the presence of liquid water beneath the surface. The discovery of active geology on Pluto further increases the possibility of life on this planet. On Earth as well, geological activities play a major role in supporting life. The discovery of similar subsurface activities on Pluto also raises many questions. Can life exist in these extreme environments? To answer this, we need to know what the conditions for life are like on Earth in such extreme environments. Our planet Earth is a place where life can be found even in very extreme and inhospitable places. For example, deep-sea hydrothermal vents are the basis of an entire ecosystem where organisms rely not on sunlight but on the energy released from the Earth's core. They support themselves with this energy. These organisms produce energy from chemical energy, which is called chemosynthesis, where bacteria convert chemical compounds like hydrogen sulfide into energy, which also serves as a source of food for these organisms. Similarly, life has also been discovered beneath the icy peaks of Antarctica. Traces of life have also been found in acidic hot springs and even in rocks found deep underground. These extremophiles are organisms that are able to survive even in extreme conditions. This shows that life adapts itself to almost every kind of environment, and in this way, it is found almost everywhere on Earth. If life can be found in such extreme environments on Earth, then it's not hard to believe that absolutely. Similarly, traces of life could also exist on Pluto. If there really is a subsurface ocean on Pluto, then it could be an excellent source for life to develop there. Although this ocean would be extremely cold and dark, life would still find a way to adapt to such an environment. Just like Earth's extremophiles, they would also rely on chemical reactions for energy. Besides this, the ammonia and complex molecules found on Pluto indicate that the building block elements of life are also present on Pluto. On Earth, ammonia plays an important role in the formation of amino acids, which make proteins and are the foundation of life. If similar chemical processes are also taking place on Pluto, then life like that on Earth could also be seen on Pluto. But the thing to note is that while the conditions on Pluto are certainly suitable to support life, we have not yet found any signs of life on Pluto. The evidence of subsurface oceans and geological activities is certainly surprising, but this is not proof of life on Pluto. To find life on Pluto, we will have to explore further. Whatever we learned about Pluto from the New Horizons mission was truly astonishing, and this mission has greatly enhanced our understanding of Pluto. And there are also some new questions that often arise in our minds about the possibility of life on this distant world. To find answers to these questions, we will have to send missions to Pluto in the future. There is currently an existing proposal to study Pluto, which involves sending an orbiter and a lander to Pluto. With the orbiter, Pluto can be studied in even more detail. Its atmosphere can be analyzed, surface mapping can be done, and the science of geological activities will be explored. On the other hand, the lander will give us direct measurements of Pluto's surface and subsurface. It will help us find signs of surface oceans and the possibility of life on Pluto. Another potential mission could send a probe into Pluto's atmosphere to study its surface and atmosphere. In this mission, advanced instruments will be used to determine the composition of Pluto's atmosphere and surface. After that, the focus will be on searching for organic molecules and such compounds that either support life or indicate the possibility of life. Apart from missions sent directly to Pluto, in the future, by exploring the Kuiper Belt, we can search for signs of life on the outer edges of the solar system. The Kuiper Belt is filled with many other dwarf planets like Pluto. If we find any signs of life anywhere in the Kuiper Belt, then Pluto becomes an easy target in the search for life. That's why we must definitely go to Pluto in the coming decades. These questions have always compelled humans to search for life beyond Earth. We humans have never lagged behind in searching for life, even in impossible worlds. The search for life on Pluto has taught us a lot, and we will continue to learn in the same way in the future. But this search surprised the scientists a lot. NASA launched the New Horizons spacecraft to study Pluto, and in 2015 it passed close to Pluto. At that time, the evidence NASA collected from Pluto was surprising for everyone. The evidence suggested that life is possible on Pluto, but how could this be? How can a small planet floating in the dark, gloomy space possibly support life? It was also hard to believe that Pluto could even compete with Europa and Titan. So what exactly did New Horizons send in its data that completely changed our perspective on Pluto? There are mountains here, passes, valleys, glaciers, and places where oceans of nitrogen are frozen. There is a thin, light, and hazy atmosphere, but it's hard to say just by looking at it whether Pluto is really suitable for life. In fact, Pluto doesn't seem suitable for life in any way. Here, the suffocating carbon monoxide and the deadly temperature of -240 degrees can kill anyone. But if we look at it from a scientific perspective, the habitability of any environment is measured by three things. First, energy. Second, organic molecules. And third, liquid water. Yes, liquid water. As far as we know Pluto, without any doubt, we can say that Pluto has an energy source and astronomers. So, even before the New Horizons mission, it was known that 2/3 of Pluto is made of solid rock and 1/3 is made of ice. Just like our Earth. The radioactive decay occurring in its rocks has been releasing heat on a geological timescale, and this heat source is the dominant energy source for Pluto. This provides Pluto with enough energy that it heats the rocks present in Pluto's interior, bringing them up to their melting point, internal. Apart from this, radioactive decay is the second source of heat on Pluto. Gravitational energy is less, but it still contributes a significant amount of heat. In internal heating, scientists don't know if we have Earth. This radioactivity is driving certain chemical reactions in the water and rocks inside Pluto or not. It is also happening just like we see in Earth's mid-ocean ridges, but it is completely clear that Pluto has an energy source, and that's important for habitability. If we look at the second thing, organic molecules, Pluto also has them. Pluto's atmosphere contains about 0.3% methane. And besides this, most importantly, New Horizons discovered that from solar ultraviolet radiation, these methane molecules are splitting into other hydrocarbon compounds such as acetylene, ethylene, and ethane. So these can also be seen on Pluto's surface. This reddish material that you see accumulated on its surface, these are the particles of the haze of the same hydrocarbon. This reddish material that you see accumulated on its surface is made up of the same hydrocarbon haze particles that have settled down from its atmosphere. That's why at least organic molecules are present on Pluto's surface, which can give direction to life and could be a reason for the emergence of life. But it's still not clear whether any such mechanism exists here, because of which organic molecules are also found in the objects of the outer solar system. Just like we've seen on Pluto. After this, to reach habitability, Pluto will have to clear the last hurdle, which is the presence of liquid water. As I told you earlier, radioactive decay inside Pluto releases a significant amount of energy, and over geological timescales, it has released this much energy until now that the ice frozen on Pluto can melt several times. Even before the New Horizons mission, astronomers knew that there could be a liquid ocean beneath Pluto's surface, right beneath its thick ice shell, although there is no assurance that such an ocean actually exists inside Pluto's inner surface, because many scientists believe that heat is being transferred slowly through convection from the insulating ice shell. Just like it happens in Earth's silicate mantle, this convecting shell removes heat from the interior very quickly. Because of this, it is possible that an ocean may never have formed beneath Pluto's surface. That's why this theory stands alone. It doesn't actually tell us whether oceans really exist on Pluto or not. To find this out, we might need spacecraft observations. Whether there really are oceans on Pluto, we have 3 lines of evidence that point towards the possibility of an ocean beneath Pluto's surface. The first evidence comes from observing the subsurface geology of the dwarf planet Pluto by closely observing Pluto's surface. We found out that its surface had very large cracks and fissures which have scarred its surface. These faults, some of which pass through old impact craters and reach deep into its surface. This shows that a global expansion has occurred on Pluto. There can be only one reason for such expansion throughout the planet's interior: the freezing of all its oceans. We know that when water freezes, it turns into solid ice. The molecules of water align in a pattern, and the volume of that water increases after freezing. In the same way, it's possible that the ocean of water inside Pluto froze, and as a result, its volume increased. This would have pushed its surface outward and caused cracks to appear on Pluto's surface. This frozen ice would have then started putting pressure on the water beneath it, and later that pressure must have exceeded a certain limit, and then it started erupting onto Pluto's surface. Scientists call this cryovolcanism. Active cryovolcanic eruptions can also be seen on Saturn's moon Enceladus, but on Pluto, we have found very little evidence of this. Between 2 large structures, a mysterious deep pit with raised edges, and its edges suggest that it could be a cryovolcano. But this alone was not enough to convince the New Horizons team. And then, the discovery of strange colors in the cracks on the surface and in the surrounding area and their composition. This is not strong evidence that the material came from Pluto's interior. And again, no one will accept this interpretation either, because here, geological evidences don't have any specific meaning. Along with that, fracturing and cryovolcanoes, both of these are not consistent with that thing. As the scientist is saying, there was an ocean beneath Pluto and it gradually froze. These things don't really match up. The second line of evidence is a feature of Pluto that Pluto doesn't even have. But scientists believe that Pluto should have this, and this really surprises the scientists. When 2 bodies like Earth and the Moon, or Saturn and its moon Ioctus, when moons orbit a planet due to gravitational interaction, their equators appear more bulged out compared to the poles. This is also called bulging. This equator bulge forms when, in the past, the moon used to spin rapidly, and that bulging gradually becomes permanent over time. This is also the case with Saturn's moon Ioctus, and it can be seen in every body that spins very fast. Scientists believe that Pluto should also have such an equatorial bulge because Pluto must have been spinning very fast in its early days. But Charon must have gradually slowed down Pluto's rotation, so the bulge that formed on Pluto due to both of them spinning should still be present on Pluto. But New Horizons has not detected any such bulge on Pluto, so scientists think that this is only possible if a subsurface ocean has formed beneath Pluto's surface and the ice shell on its surface was not strong enough to support that bulge, so it must have collapsed. And this is the possible explanation that there is an ocean deep inside Pluto. The last line of evidence for the presence of an ocean on Pluto is the most complicated and the strangest. It starts with the largest bright basin on Pluto's surface, Sputnik Planitia. This entire basin area is so bright because it is covered with frozen nitrogen ice, which fills the whole basin. This ice comes from the nitrogen glacier, from where it flows and spreads to the surrounding areas. There is another amazing fact related to Sputnik Planitia. This region lies in exactly the opposite direction from the side of Pluto. From the side of Pluto that always faces its moon Charon. Let me tell you that Pluto and Charon are tidally locked to each other, so the same face of each always faces the other. So in this case, if we add some extra mass to that planet, like a big mountain, Pluto will rotate in this way, until that extra mass reaches Sputnik Planitia. Scientists call this process true polar wander, or TPW. Because of TPW, Pluto's surface gets distorted when any extra mass is added to it, and due to this, we can see expansion, fractures, and many other kinds of features on Pluto's surface. For scientists, the location of Sputnik Planitia makes perfect sense if it behaves like an extra mass. But now the question is, how can this basin behave like an extra mass? After all, it's like a crater on Pluto's surface, so the explanation could be that as nitrogen ice from the glacier flows and fills this crater, it becomes a bit denser than water ice. And in this way, this basin contributes a little to the extra mass, but the contribution of ice is very small. Another explanation is that the reservoir of water ice beneath it melted from below the surface, making the ice shell thinner and turning into liquid water, so that water acted like excess mass. If we combine nitrogen and the thin ice shell, then this excess mass is capable enough to produce TPW. So this explanation also points towards a water ocean inside Pluto. So New Horizons has provided 3 lines of evidence that there could be subsurface oceans on Pluto. No. 1. Surface fractures and possible cryovolcanoes. No. 2. Absence of equatorial bulge. No. 3. Sputnik Planitia represents excess mass. Although none of these lines of evidence are bulletproof, if we consider all of them together, the likelihood increases many-fold that there could also be water oceans on Pluto, the events happening there, and the conditions there are in favor of this, suggesting that there is definitely some water ocean there. To prove habitability on Pluto, we needed 3 things. First, an energy source, which Pluto has. Second, organic molecules, which are abundant on Pluto. And third, water, the search for which has not yet reached any conclusion. So exactly how will we confirm water oceans on Pluto? Because this is the last link to prove habitability on Pluto. For the past 2 decades, scientists have been using several techniques to search for subsurface oceans on ice bodies. But unfortunately, the best techniques we use among these can't be used on Pluto. The first technique requires a background magnetic field, which induces currents in the body's salty water ocean, and then scientists can study the secondary magnetic field created by these induced currents to confirm the subsurface ocean. This technique works very well on Jupiter and its moons, but in the case of Pluto, there is no large background magnetic field here that can produce such signals. The second technique is to measure the size of the tides formed on the body. The bigger the tides, the higher the chances of there being a water ocean. But here too, Pluto and Charon always keep the same face towards each other. Because of this, no effective tides are produced. So, both these methods do not work on Pluto. Because of this, confirming the presence of an ocean on Pluto is a tough task. And for now, The search for water on Pluto remains a mystery. So now the question is, how habitable is Pluto and can we expect life here? So look, Pluto is a small planet revolving billions of kilometers away in the dark, although its interior is warm. Organic molecules are also found on it, and lines of evidence suggest the possibility of a subsurface ocean here. This makes us think that this small world fulfills the basic requirements of habitability, but that doesn't mean at all that Pluto is a paradise. That doesn't mean Pluto is ideal for life to develop, because we don't know how much these three things, energy, organic molecules, and water, can actually interact with each other. However, it's possible that the rocky core is able to properly transfer heat to the water ocean above it. But even then, we still don't know for sure if this actually happens. And if organic molecules are found only in Pluto's atmosphere, then Pluto would need a mechanism for those organic molecules to reach its interior so that life can begin its first form. But our evidence suggests that Pluto's shell is cold and rigid, and there is probably no mechanism that would allow these organic molecules to reach its subsurface ocean. That means Pluto has all the ingredients, but because it is isolated, there is always a sword hanging over the possibility of life and habitability there. And that's the reason why Pluto isn't as tempting a target for us as Europa and Enceladus, wherever the ice shells are moving and thin. But even then, Pluto could be a better option than other big moons like Ganymede and Titan, wherever thick and high pressure ice layers break the connection between the ocean and the heat source. Pluto generates so much heat that it can comfortably sustain subsurface oceans for billions of years. But to confirm the existence of life on Pluto, we will have to send more missions. And we also have to keep in mind that Pluto is the key link between our solar system and the Kuiper Belt. This can give us a new dimension to explore the outer solar system. But Pluto is not unique either. There is a high possibility that other Kuiper Belt objects also have such subsurface oceans. And finally, to map Pluto's poles in darkness, we will need advanced and active instruments like LiDAR, which will help us detect the temperature changes occurring on Pluto's night side and day side. And to do all these tasks properly, we will need an orbiter. And that orbiter should not be designed for just a day or a few days, but for years of operation, which keeps sending us data week after week and continuously keeps an eye on Pluto and its moons so that we can observe their geology and atmosphere as they evolve. Mission design. This mission concept for Pluto is ready, but designing this mission is the next most challenging step. A team of scientists at the Southwest Research Institute spent a full 2 years researching how to place an orbiter in orbit around Pluto. The research found that to launch a spacecraft of New Horizons scale with advanced instruments, a new Saturn V class launch vehicle would be needed. We would need Jupiter's gravity assist, a nuclear electric stage, and a chemical propulsion braking stage. To reach Pluto, scientists found in the study what kind of payloads the orbiter should have, what kind of orbiter tour would be possible, what the main attributes of the spacecraft would be, and how the spacecraft would be sent from Earth to Pluto. The biggest breakthrough that came from this study was the solution to the propulsion system requirement for reaching Pluto. At first, the researchers added a lot of propellant mass to the spacecraft, but later they found that the propellant needed to explore Pluto and its moons could be eliminated. By performing a close flyby of Pluto's largest moon, Charon, that is, by using repeated gravity assists, this would be much like the missions sent to explore Saturn. It's similar to the Cassini mission, which used the gravity assist of Saturn's largest moon, Titan, to study Saturn and its moons. And when the team of scientists simulated this idea, it worked perfectly, which completely eliminated the hassle of carrying most of the fuel. After the timeline mission design, the scientists created the timeline of this mission in this way. This mission will be launched in December 2028. In December 2030, it will fly by Jupiter and increase its speed using a gravitational slingshot. In 2046, it will use braking to enter Pluto's orbit, and this mission will be completed in the year 2069. We could reach Pluto even faster if we had a high-power nuclear system to increase braking thrust, which would allow the spacecraft to slow down quickly when it gets near Pluto. But for now, slow trajectories are the only feasible option for us. This mission will study Pluto and its moons for 2 years. The braking maneuver will be completed using Charon's gravitational assist, and after that, the spacecraft will be placed in Pluto's orbit. The orbit around the planet will last for a few weeks, and during this close flyby, it will explore each of Pluto's moons. Dozens of such flybys will be conducted, and more than 30 close flybys of Charon alone have been planned. This will allow the spacecraft to map Pluto in both equatorial and polar orbits, and it will also be able to collect samples from its upper atmosphere. Although this mission will last for quite a long time, the spacecraft will have to complete all its objectives within the set period of 2 years. But because of the flight system, the orbiter's payload mass will almost double. The weight of a full-fledged spacecraft system, along with the electrical and chemical propulsion system, will be around 2,349 kilograms according to current estimates. However, the launch vehicle that the scientists have chosen can launch even 30 kilograms more payload into space than this. Even though most of the orbiter's capabilities will be similar to New Horizon, there will still be some differences. And here, we will talk about the 3 primary differences between the proposed orbiter and New Horizon. The first is that the orbiter will need more onboard fuel because it will have to make continuous corrections to its orbit during its mission period. In addition, fuel will also be needed to continuously operate the reaction wheels to stay stable at one point in the orbit, whereas the amount of fuel in New Horizon was quite low. The second thing is the need for larger onboard data storage. New Horizon was sent with 16 GB of onboard data storage, whereas the orbiter will have to work more frequently, so reliable data storage becomes necessary. The third and biggest change will be regarding a more capable communication system. The communication system that was made to return the data from New Horizon's single flyby mission. It completed its work in 16 months, which is not useful for an orbiter, as an orbiter will have to send the collected data to Earth every 15 to 30 days. For that, a much larger dish, antenna, and transmitter will be needed, which will have to be about 10 times more powerful than New Horizon. Along with this, it will be capable of removing background noise from its images and spectra using its software. And fortunately, we don't need to develop any new technology to make all these changes. This mission is feasible with our existing technology. Before 2015, that is, before the exploration of Pluto, most planetary scientists thought that after New Horizons, a natural follow-up flyby mission should be done. This would allow all the dwarf planets of the Kuiper Belt to be explored as well. In this way, we can explore the diversity of dwarf planets in the same way that the Mariner, Pioneer, and Voyager missions carried out exploration. They first studied the terrestrial planets and then all the gas giants. However, after witnessing the spectacular complexity of the Pluto system, scientists are now confused because there is so much to study in the Kuiper Belt, dwarf planets, and planetary bodies. And several groups of scientists are arguing among themselves that Pluto should be studied in depth. By sending an orbiter mission, while some communities are in favor of a flyby mission like New Horizons, so that we can study more than one Kuiper Belt object like Pluto. In this regard, the scientists' research team got another big breakthrough that with the Pluto orbiter mission, we can accomplish both tasks. We can do a deep study of Pluto and also go wide into the Kuiper Belt to explore other bodies. To combine both these missions into a single mission at an affordable cost, we will have to look at the profits and losses on both sides. This will be a kind of tug of war. Scientists have referred to the results that will come from going wide in the Kuiper Belt to study other dwarf planets and going deep to study the Pluto system. All in one concept, the gold standard Pluto Kuiper Belt exploration mission. Now, what is this new term? The gold standard. Does the game-changing gold standard mission work like this? First, there will be an orbiter tour of Pluto, and Pluto will be studied in depth. After that, by performing a gravity assist flyby of Pluto's moon Charon, the orbiter will be sent out of Pluto's system and further into the Kuiper Belt. That too without using any propulsion. After that, using the already existing technological capabilities, specifically the electrical propulsion system that NASA has used in its Dawn mission, The spacecraft will be able to explore and study more than half a dozen small objects in the Kuiper belt, including several dwarf planets. In fact, in many scenarios, the Dawn propulsion system can be used to take the Pluto orbiter out of the orbit of one dwarf planet and send it on another orbital mission as well. This technology can truly prove to be game-changing for this mission. The breakthroughs achieved from this research have ended the debate over whether the next mission should be a flyby mission like New Horizons or a Pluto orbiter mission. It's pointless to have this debate because only one mission can do both tasks, and currently no major space agency has planned such a mission. But it's possible that it could be launched in the late years of the 2020s or 2030s. This will have a major impact in the field of planetary science studies. Planets, planetesimal formation, ocean worlds, exotic atmospheres, and dwarf planets, how they work, and even our exploration in astrobiology will expand. This mission will prove to be a major milestone in space exploration and perhaps will be remembered for even longer than Voyager, a small mysterious world orbiting the sun in the darkness of space, even beyond the last planet of our solar system. Pluto, which is also called the god of darkness, whatever we know about it today is still very little. Every day, scientists are constantly learning something new about this mysterious planet. Our journey to understand Pluto goes from this pixelated image to some high-definition images like these. We have been able to understand its atmosphere, its geographic features, its moon system, and some of the processes taking place on it in a much better way. But even today, many mysteries are still buried on this small planet with a diameter of about 12,500 kilometers. We definitely need to think about these. But even after knowing so much, there are some misconceptions related to Pluto that people have in their minds which are absolutely not correct. There are some questions for which people think they have the answers. But with changing times, either those have become outdated or they are completely wrong. For example, was Pluto named after a Disney character? Was Pluto ever a moon of Neptune? Or is Pluto an icy world? There are many such questions that revolve around Pluto. So, in today's journey, we are going to travel to our dwarf planet Pluto and learn about some myths about Pluto that you might also believe in. Myth number 1. Pluto was first the name of a Disney character. If you look at the chronology of these Disney characters, this myth will end right here. Pluto was discovered in 1930, and although the famous Disney dog also debuted in 1930, the dog's name was originally Rover. There was also a character named Pluto the Pup, but he also debuted in 1930 and was not broadcast until 1931. People were saying that the girl who named the planet Pluto took the name from Pluto the dog, but now it is proven that the dog's name Pluto was inspired by the planet. Let me tell you that when Vanity Fair was a schoolgirl in 1930, she named this planet Pluto. In 2006, Pluto is tiny. Even today, many people think that since Pluto is a dwarf planet, it must be very small, about the size of an asteroid. But let me tell you, Pluto has a large size with a diameter of 2,360 kilometers. That's about 2/3 the size of our moon. And it can even be compared to Jupiter's ocean world moon, Europa. It can also be compared to the ocean moon, Europa. Not only that, Pluto's largest moon, Charon, is about half its size at 1,207 kilometers, while Pluto's diameter is 2,360 kilometers. That's why these two are sometimes called a binary system. Scientists believe that Pluto is the largest object in the Kuiper belt, meaning that after Neptune's orbit, Pluto is the largest object. In the Kuiper belt, comets are found in the majority, but Pluto is the largest object, meaning that after Neptune's orbit, Pluto is the biggest object. Comets are found in the majority in the Kuiper belt, which are only a few kilometers in size. Some comets can be hundreds of kilometers in size, but Pluto is even bigger than other dwarf planets like Eris. Myth number 3. It's dark there all the time. Pluto's orbit is on average 4.8 billion kilometers away from the Sun, and that distance is really very great. From Pluto, our Sun looks just like an ordinary star, but a bit brighter, and that's why some people believe that Pluto's surface is always in complete darkness for 24 hours, but that's not the case. During the day, Pluto is not as dark as people think. It's somewhat like what happens on Earth when there are dark clouds. Or it's as dark as it is here on Earth just before the sun is about to set. That's about how dark it gets on Pluto as well. This means that if a person goes there, he will definitely be able to see everything, but in some cases, we might need lighting there. Myth number 4. Pluto was once a moon of Neptune. This is an old theory which became popular right after Pluto was discovered, and in 1965, this theory was disproved. People used to think that Pluto was not a Kuiper belt object because Pluto is perfectly round, while Kuiper belt objects are not that round. Its structure looks like that of a planet from our inner solar system, and that's why people had this misconception that Pluto is a moon of Neptune, and for some reason, it got separated from Neptune. But later, when these two bodies were studied using the concept of orbital resonance, it was found that these two bodies were never that close to each other, which completely eliminates the possibility that Pluto was ever a moon of the planet Neptune. Myth number 5. High-resolution images of Pluto have been taken by modern telescopes and the New Horizons spacecraft, in which we could clearly see that Pluto is completely covered in ice. And this ice is not just made of water, it is made of frozen nitrogen, frozen methane, and so on. If we look at Pluto's density, we find that its density is almost double that of water ice. The conclusion drawn from this is that 2/3 of it is made of rocks and 1/3 is made of ice. So, it would be more accurate to say that Pluto is a rocky body with only its surface covered by ice. Myth number 6. In 1980, scientists discovered an atmosphere on Pluto. Pluto's atmosphere was found to be mostly nitrogen. Just like on Earth, Pluto's atmosphere also contains a significant amount of carbon monoxide and methane. However, even then, if compared to Earth, Pluto's atmosphere is very thin, and compared to Earth's atmosphere, it extends much farther into space. For example, Earth's atmosphere extends up to about 600 kilometers, which is roughly 10% of Earth's radius. But if we talk about Pluto, its atmosphere extends up to 7 Pluto radii. That means the volume of Pluto's atmosphere is about 350 times greater than Pluto's own volume. And that's why it can't be said at all that there's no air on Pluto. There definitely is air on Pluto. But whenever Pluto goes very far from the sun in its orbit, all the gases in its atmosphere freeze because of the cold. And then there is a lack of air there. But when Pluto comes closer to the sun, the ice melts and the amount of air and gases in the atmosphere increases. So this is how Pluto's atmosphere works. Myth No. 7. Pluto's orbit is one of a kind. Pluto's orbit around the sun is not perfectly circular, but rather elliptical. It comes as close as 4.43 billion kilometers to the sun, and at its farthest point, it is 7.36 billion kilometers away from the sun. Along with this, Pluto's orbit is tilted at an angle of 17 degrees to the ecliptic plane of our solar system, and compared to the orbits of the other planets, Pluto's orbit is quite different. Along with this, Pluto's orbit crosses Neptune's orbit. Because of this, for about 20 years, it remains inside Neptune's orbit. Because of this, in 2006, the International Astronomical Union unanimously removed Pluto from the official list of planets and included it in the category of dwarf planets. But if we look at Kuiper belt objects, other dwarf planets like Eris and Haumea have orbits that are even more elliptical and inclined than Pluto's, so why not Pluto? It exhibits characteristics similar to extreme Kuiper belt objects and not those of our official planets. So friends, these were some myths that are quite popular among people, but the truth is quite different from them. Pluto has many more mysteries like these that continue to surprise us. We have talked about this in a related video, so do check out that video. You will find the link in the I button above and in the description box below. And friends, did you ever believe in any such myth or not? Do let us know in the comment section below. If you like this video, make sure to like it and share it with your friends as well. For more videos like this, stay curious, be happy.